Thank you for watching the Housing Oregon YouTube channel. Please like and subscribe. Slide decks from the presenters are going to be available below. Thanks for watching.
Just so you know, you're in the right place. This is Mass Timber Applications in Affordable and Workforce Housing. My name is Jill Reese. I am the Deputy State Director for USDA's Rural Development Programs in Oregon. We do a lot of things at USDA. My division of USDA works in housing. Am I loud enough? Okay, I'm catching the signals from the back. We fund housing, we fund transitional housing, multifamily housing, farm labor housing. We fund the construction of community facilities, things like hospitals, schools, you name it. And we also do business development. So when you think about mass timber, there are a lot of ways our programs can touch mass timber as it is more commercialized. So today we wanted to have a conversation just about where we are with mass timber in terms of bringing it to housing as a viable solution, affordable solution, what needs to happen yet, and how we can support what's going on. Again, there's been significant investment in developing mass timber in Oregon through the state, the Department of Commerce, EDA, and USDA with the Forest Service, et cetera. So we are going to talk about the early investments into what they have achieved and identify the value and pathways forward for mass timber in affordable and workforce housing. How's that sound? Fascinating, right? Yes. Okay, so I have this esteemed panel. I'm so excited to have this group. I'm going to let you guys introduce yourselves, and then I'm going to ask a series of questions. Then we will open it up for questions after everybody talks and see what you guys have to say, okay? All right.
Hello, my name's Austin Basil. I'm with Ferris Engineered Wood, and I am a sales engineer. So structural engineering background, just technical sales, more or less. So.
Hello, my name is Drew Schreiner with Base Design Architecture. I've been working with Jill and her team on implementing MPP into modular systems here with Nathan Young.
I'm Nathan Young, owner of Mods PDX, and working with the USDA on implementing Ferris's MPP into our modular volumetric systems.
Hi, I'm Judith Shine. I'm a professor of architecture at the University of Oregon and the director of design for the Tallwood Design Institute. And I've been working on a project. I think apparently I'm the only one with slides. So you'll be seeing it, right? And I'll talk more about the Institute when Jill asks me about it.
Thank you. Hello, everyone. My name is Leticia Cervantes. I'm working with Hacienda CDC. I'm the innovation director, and I feel really thrilled about sharing this table with these incredible people. Thank you for being here.
Thanks, same. My name is Anna McKay, and I am the principal of Sister City, which is a real estate development company based here in Portland. My partner and I are co-developing a series of housing projects called Short Stack, and they utilize mass timber and wood stud walls that are pre-framed before they get to site. And so we have a hybrid system for our multifamily projects, and I'm really looking forward to sharing the conversation with y'all.
Are you guys kind of warm? If we could maybe open the doors again, it's quieter in the hall now. So let's start at the beginning. Let's start with production. Austin, you're on the hook. Why don't we start out with what is mass timber for the folks in the room who might not have heard about it yet? And how is it different from heavy timber construction?
So mass timber is, generally speaking, just large wood members, either in a slab or beam and column format. It's typically made from engineered wood products, and it's typically prefabricated. So it comes to the site and just ready to install. So there's nothing getting cut on site. With heavy timber is basically its older counterpart, maybe typically not as big of members, more solid sawn, and it's a different part of the code, so it's just designed with differently.
So, and I didn't give you this question in advance, but I know you've got this. What was the idea behind mass timber in terms of the value in the forest? And as far as the timber industry?
So the value in the forest. I mean, basically, the reason why we went with mass timber is to increase our value add to our product line, and how that relates to the forest is, you know, basically with the engineered wood, we can use smaller trees to make bigger members. So back in the day, if you needed a big beam, you needed a big tree. Well, now, you know, our average log diameter is like 8 inches in diameter, and then we can make a beam that's 6 feet deep and, you know, 12 inches wide and really long. So the wood basket that we pull from is a lot different.
Thank you. And can you talk a little bit about different types of mass timber? You hear about cross-laminated timber, mass plywood, et cetera. What's the difference, and should we care?
Yeah, they're all a little bit different and have some unique, I guess, advantages. Mostly it's CLT, MPP, that you see, you know, glue lam, and then big LVLs for beams and columns. You know, the CLT, MPP are big slabs of wood that, you know, can go up to 12 feet wide, up to 48 feet or 60 feet long, depending who's manufacturing them. And those are a little bit more versatile in design because they have biodirectional spanning capability. There are other forms of mass timber, such as NLT, DLT, and GLT, which is more, you know, a bunch of lumber that's made into a mat, and they have their advantages, you know, as far as there's some acoustical advantages and some longer span capability. But they're a little, they don't have like the biodirectional capability like the CLT, and so they have all their different places. Yeah.
So I'm going to put a couple questions together since we're passing this back and forth. For what Ferris Lumber is producing right now, incoming orders, is how much of that is for housing? And how many of those projects are kind of one-offs?
Yeah, I mean, we get a little bit of everything because I think because we are a new innovative product, we get a lot of innovative early adopters in. So we see almost a little bit of everything, but the majority of it is geared towards housing, you know, whether it's, you know, modular or, you know, I guess different construction types to build faster. And then, you know, the remaining part's probably more institutional, a lot of school stuff and things like that.
So we hear a lot that mass timber can be expensive. What on your end at the production side would make it more cost effective for those who are building things?
Yeah, it really just comes down to the raw material. So the wood, the wood's the biggest expense item that we have. And so, you know, we're trying to drive down our costs as much as possible just to get it out there. And, you know, we have some of the largest wood costs in the whole entire world. So it really just comes back to forest management. You know, we're seeing a lot of forest fires, and there's a large amount of wood volume out there in our forests, especially historically. And so, you know, we are seeing, when we see forest fires, we're seeing more intense forest fires because of this increased volume. And so forest management, as far as getting in there and trying to, you know, whether it's thinning, get more wood out of the stand so it's a healthier stand, we increase that volume, our costs go dramatically down, and now we can start replacing more concrete and steel, which is, you know, obviously a lot more carbon intensive compared to sequestering it and storing it in a building.
How can the housing production community support greater adoption of mass timber?
Uh, yeah.
Swipe the credit card.
Yeah, right. I mean, I think the big, it always comes down to education, right? Trying to inform people that, would, that's where we have Judith over here for, and she's, training her early architects to understand mass timber and just the general public as well, just, understanding that wood is a sustainable material and it's, a very eco-friendly material where, we can take this carbon that these trees are naturally pulling the carbon out of the air, storing it in wood fiber, and we can create this building material that can last hundreds, if not even thousands of years. And so I think that's a big part of it. And then, just basically I guess, far as starting small too, just whether then, a lot of people have a hard time, dipping your toes into it. So maybe picking a smaller element of the building, like a corridor, and implementing that and getting people familiar with it. Because, if you, like I was talking about earlier, we get these early adopters that can, aren't as fearful of jumping right in. And then the majority of people, they want to stick to what they know. So, getting just a little tiny piece to where they can start getting familiar with it, I think will open the doors for more adoption. So,
Thank you, Austin. Now I get to pick on Drew. Drew, you're going to represent the design side as the architect. What drew you to mass timber? Why did you start working with mass timber?
So I want to just piggyback on what Austin said here is that our path is really, I think, what we have started small with a small idea. Really, a lot of our work is collaboration with Nathan here at Mods PDX. And it was a simple ask of how we can incorporate MPP into our designs. Nathan's been instrumental in identifying the efficiencies and how to standardize using MPP. And it really is a team effort in terms of the ask and then quickly trying to figure out how we can design around it. Our journey really started with just an idea of trying to come up with a series of models to enter different markets with ADUs and single family housing. The MPP was really a kind of a spontaneous conversation, but then we were asked to design some on-farm worker housing to see if we can get it moving as quickly as possible. That led to more opportunities in looking at housing out in Eastern Oregon. We're trying to create some prototypes that we can mass produce and bring up the scale of production to then lower the costs and make it a viable product. So really, literally, this started about 6 months ago for us. Austin was really nice to tour us around. He takes you to the bar afterwards, so sign up for that tour. But really, it's been, I think we are hoping to be the proof of concept to be able to move and scale quickly.
Great. So what kind of design considerations are you finding that are unique to working with mass timber? And do you want to take a minute to introduce your partner who is in the audience?
Yes, my partner back there is Keegan Flanderka. Very much good guy and does great work. Yeah, Keegan was supposed to be up here, but we're dividing forces. So your question was, now you got me thrown off. Oh, I think really the message there is keep it simple. We basically, Nathan has really been instructing us in terms of what makes sense to keep the cost in check. once Austin unveils his 10% discount that he didn't mention.
Or give us.
Or give us, right? We're going to talk about that later. Really what we're trying to do is keep it simple and start to work from there. An example is we're utilizing it in our floor systems. We're coming up with a different series of trying to vault the ceilings and working with our engineer on that and just basically create a series of standard details around them. And
some of these features that are best suited for mass timberland.
yeah, I think some of the things that we're really trying to retain our standards of the mod and the what makes sense in reducing the amount of parts and pieces. So we're really, the floor was a home run. We're trying to create a series of stackable mods so that we can enter more of the multifamily housing. It offers, we're going through a series of testing with Judith and the Tall Lab. So we're still very at our infancy of trying to figure out what makes sense, but it's really, the modular does seem to make a lot of sense of in facility utilizations as for the components of it.
To Nathan.
They're done with you.
When I ask it, so we don't have to pass the microphone.
Yes.
No, not that restricted. Why did Mods PDX start using mass timber? What brought you into this?
So the question is, why did mods start using mass timber? Well, my partnership with base design and architecture with Keegan and Drew is instrumental to this. We were actually asked by Margit, the USDA, how to look at implementing some mass timber into our modules. And quite honestly, in the beginning, we kind of thought it was not something that was necessarily going to be applicable to us. We then started meeting with our engineer and collaborating, and through the collaboration with our engineer, we were able to look at the importance of what the MPP does from a diaphragm standpoint. So our conventional floor systems right now are made up of anywhere between 90 and 120 pieces by the time you count hangers and joists and everything that goes into it. It's about a 4.5 to 5 man day process to build a single floor and get it squared up and ready to go. By going to the MPP, we're able to convert that down to less than 14 pieces, depending upon the length of the unit, and convert that in an estimated time frame of less than a day, 1 man day. So from us, it's purely an efficiency standpoint that we looked at using the MPP. It makes sense from us from a time standpoint. The cost is a little bit more expensive material-wise, but the labor savings is significant, which then can increase our volume. Since labor is such a significant issue, we were able to increase our production output. So for us, it's purely an efficiency standpoint. Then when we looked at doing the ceilings, it added some mechanical, electrical, plumbing, or MEP issues to us that we're trying to work through. We are doing a hybrid model, so we have a conventional wall system, partly because when we looked at the MPP from a vertical standpoint, there's too much rigidity in it oftentimes, and so you run into some issues in the shear components of it from what our engineer was looking at. Just from our standpoint, I'm not saying every building. So for us being a modular application, the MPP works perfectly because it decreases the amount of labor that's going to go into building one of our volumetric modules.
Housing, have you been building then?
So we haven't done anything with the MPP yet. We got our first order of MPP last Monday, but in the modular space, we've done every typology there is. We've done apartment buildings, we've done institutional office spaces. So for us, the conversion to MPP isn't dramatic. It's just simply a modification of changing what is a 4x8 sheet to a 12-foot by 15-foot sheet. I mean, so it changes some of the product components to us, but it doesn't change any of our processes. So we're very process oriented in the way that we look at it, both from a design standpoint. So when Drew's talking, the constraints that they have around their design are my constraints or constructability constraints that we come up with together. So we all work together to try to achieve the right design intent behind what the end goal is going to be. We've been doing modular together now for almost a decade, between Keegan, Drew, and I, on the design side and the build side. And so if you look at our website, none of our houses or none of our buildings, you would ever know they were modular, except for one that we purposely designed that way, which was the Willamette building. But other than that, I mean, our goal is to try to utilize the volumetric modules to create all sorts of different typologies. The implementation of the MPP doesn't constrain us to single family. Some of our first prototypes that we're doing, I wouldn't even say prototypes because they're not prototypes. The first units that we're doing are going to John Day and happen to be cottage clusters. We have an ADU in the shop right now that we're going to go through and work out the MEP constraints and some of the issues with the subs on in the next couple of weeks, just so that we can vet out any potential issues that we see in the implementation of the MPP. But for us, it's not a significant change.
Folks working in the construction industry who haven't used this product before, what are some of the learning curve considerations, adjustments that need to be made?
I don't know. I'll let you know when I figure them out. I mean, we've done some stuff with CLT in the past, and so anytime you're moving larger panels around, it's more the rigging and the application of moving around the facility. We have 13 overhead cranes, so we're not constrained to the same limitations that you are on a site-built type project, where we can allocate our builds appropriately, and we specifically designed 2 rows, 2 build sections where we can utilize larger panels and use the overhead cranes to move them into place. You're not moving as many parts and pieces. You do have to do a little bit more or a little more thought in the design side as far as coring through it, because our floor systems are 5 inches thick. So you're not just going to take a hole saw and go through it. So we've had to work through the MEP, which is why we're building this first ADU, is just to confirm that we've got all of that kind of figured out between the electrical and plumbing and mechanical, so we can get the accesses pre-cut, because Freres has an amazing CNC system and the capacity to be able to modify the panels. Part of our goal is to be able to create a reproducible unit that minimizes the amount of fabrication, but yet utilizes the optimization of their fabrication to increase our efficiency. So we don't want to design panels that are all individually unique, never to be built again, but we want to design panels that allow them to be able to increase their production to commoditize the MPP as much as possible. Money. So we're going to pass a basket around here. If we could just start collecting some money now. I mean, really for us, it's just about implementing it into projects. So moving forward, as of a couple months ago, we will not be building any modulars with a conventional floor. All of our modules now will have an MPP floor, irregardless of what the typology is. It doesn't constrain the finishes, because somebody's probably going to put something else over the top of it. Certain applications, we're going to utilize it for the ceilings as well. We're coming up with some proprietary uses to be able to vault systems and create some other opportunities on the design side that really opens up some beautification to the design side, working on the constructability side and minimizing pieces that go into it so that we can still achieve a higher design intent.
Here on your phone.
Okay. And I think you're going to ask me some questions before I get to the slides on the house. Is that true?
Is that the way we do it? Let's do it that way. We're both by the microphone.
Yeah. Just stand here. Right.
Well, okay, briefly tell us about the work of the Tallwood Design Institute.
Right. The Sellwood Design Institute is a collaboration. Can everybody see me? Maybe I should. Right. I know that is an issue. Is a collaboration between Oregon State University and the University of Oregon. University of Oregon's College of Design and Oregon State University's Colleges of Forestry and Engineering. And we are focused on advancing engineered timber products for both economic development and environmental stewardship in the state. And we're supported by the state legislature, who of course loves the idea of the ducks and beavers working together. Our mascot is a platypus. His name is Bucky. Anyway, lives in the lab. So we have a really great facility at OSU at the College of Forestry called the Emerson Lab. We just had our annual research symposium on Thursday. Nathan was there, and we hope to get even more people there. I think, Austin, you've been there. I believe, right? And we have done something like 100 research projects to advance mass timber in one way or another. One of those projects was actually our faculty, that would be Andre Barbosa and Ari Sinha, worked with Frères to develop and test mass plywood. So we've had a relationship to mass plywood since the beginning. That has been very important to us.
So why don't you tell us about the single-family house that you and your colleagues designed out
All
of
right.
mass plywood?
I'm going to do that. So I should say that I've been working on this with my colleague, Mark Fretz, and another colleague of ours, Jason Stenson, for quite a long time, because for some reason it has taken us a very long time to work out the MEP and the structural connections when you don't have hollow walls, right? And if we can help by telling you about some of the stuff that we've spent time on, that would be great, because we've been doing this through a lot of public funding. We got a little bit of funding through the USDA Wood Innovation Grant, but some of you may have heard about this big Economic Development and Administration grant for Build Back Better Regional Challenge. That was led by the Port of Portland and Tollwood Design Institute. The two universities worked with the Port, Business Oregon, Oregon Department of Forestry, and with Department of Land Conservation and Development to develop a kind of suite of projects that we call Forest to Factory. So they range from smart forestry, dealing with basically modernizing logging techniques and trying to attract younger people back into logging with robotics and digital data management, through increasing the fiber supply, which, as Austin said, is ridiculously expensive now, through trying to create a market for selectively harvested products from forest restoration projects, meaning thinning, producing small diameter logs, which can be used in mass timber applications, and all the way up through the last two labs we did not have, which are a fire testing chamber, which will go up at OSU, an acoustic testing chamber that UO is doing at the Port's Terminal 2, which some of you may know is being converted into a mass timber housing innovation campus that will house factories producing mass timber modular housing, one kind or another. So the EDA, one of the projects that the EDA funded was prototyping. And we finally had funds to actually, I'm getting to the house, I promised Jill, I'm sorry, is that just for prototyping this house. And we did it in our Emerson lab with a lot of equipment that we have there for both manufacturing and for testing things structurally. So this is the house before the front and back door went in, but the house is made out of 3-inch and 2-inch mass plywood panels. And we're approaching this as what we call a panelized system. The idea is that we want to make it flat pack. We think there is room in the market both for fully modular and flat pack, where we imagine it as a kind of IKEA exercise where, a bunch of prefabricated mass plywood panels with steel connections and all the screws that you need arrive in a package, and this can go up, we think, very quickly on site. And it was specifically designed for cottage clusters and for ADUs in places where you're really dealing with infill, right? Where it's hard to get big, full volumetric modules in with a big crane, where you could actually do something that is more about infill. So speaking of IKEA, our communications team decided we should furnish the house, which we did from IKEA. So it kind of makes sense, doesn't it? So we did, in fact, furnish it's a 2-bedroom, 2-story house with living and dining room. You can see here in these photographs. On the ground floor, half bath when you walk in, and storage, including bicycle storage. It's Oregon. And then the second story is you can see you go up the stair, and we try to take advantage of the gable roof on the second story as much as possible to let light in. There's skylights and things going through. And I thought I'd just show you the bathrooms because everybody wants to see those. It's the one place where we have a hollow wall is for plumbing, and we of course tried to line it up. There's a full bath upstairs. And that's the slideshow. And
Not quite done.
oh, okay, yeah.
The next question is, what are you working on now with regard to retrofits using mass timber for multi-story, multifamily units.
Right, so a closely related project, which we also got funded to do prototyping for, is what we call a facade retrofit project. And this started, we were contacted by the Department of Energy, which was interested in a project that was going on in the Netherlands, where they came in and basically LiDAR scanned an entire facade of an existing building, went back to the factory, constructed a whole facade from that file, and then applied it in the field, including with windows without ever disturbing the residents at all, which is kind of an amazing thing. So they had this idea about using CLT with insulation for energy retrofit, which was what those were about. And Austin, you will be happy to note that I thought, of course, we should be using mass plywood because it's thinner, stiffer, and stronger, which means that it has a lot of structural advantages, but also as you're using less fiber, it's generally less expensive. So we did not get funded by the DOE, which was extremely annoying. They gave all the money to their national labs, like, why not tell us that? However, the U.S. Forest Service was very interested in this project, and they gave us some funding to do a one-story mock-up and a two-story structural test. And we needed the structural test because it's on the West Coast. And my theory was like, we should not just be doing energy upgrades, we need to do seismic upgrades. And there are a huge number of 2- and 3-story light wood frame multifamily apartment buildings all up and down the West Coast that are desperately in need of both seismic and energy upgrades. And this is designed as a mass plywood wall with insulation and cladding on the outside that can be applied on the outside, again, with windows in it. And when you're done, you just come back and remove the existing windows. So we are looking, of course, for pilot projects for that. We're about to, for the house project, we're going to be doing some optimization, lessons learned about things we could do better. And we're going to be doing a second prototype outside the lab. We're going to test many more things, including thermal. And then we did a 2-story structural test. We're doing a 3-story structural test for that. And if anybody's interested in a pilot project, please let me know. Mm-hmm. Am I done?
That kind of led to my next question, which is a lot of folks in the audience here are developers or multifamily housing builders. If they're interested, how do they get started?
If you're interested in the retrofit, you should just email me. The 3-story mock-up hasn't gone up yet. We're about to put out an RFP for it. Maybe you want to bid on that. And we'll be building it in our lab at the strong wall so we can do structural testing. And that one, I think, will actually be ready for applications. We hope, by the middle of next year, that we'll know enough about it to actually have developed drawings and as well as the mock-up and a bunch of structural tests. So if you're interested, let me know. And once we get the 3-story up, I will let you know. Thanks, Jill. Right. Any other questions? Right. Right.
Thank you. Thank you. And next, I'm going to have Leticia come up and talk about what the Mas Casitas project. We're just going to switch out laptops here. You grab that, yeah.
So do you want to?
What? Uh-oh, it's not projecting. Yeah, exactly. It could just. Oh, yep, there we go.
So,
Start the photo.
so I need to.
Start the presentation. Here.
Perfect. Thank you so much. Thank you, everyone, for your patience. Again, my name is Leticia Cervantes, and I'm with Hacienda CDC. So just real quick for you guys, Hacienda CDC is a Latino-led organization. And we strengthen families by providing affordable housing solutions, among other programs, focus on economic opportunities and also education for the people that are part of the communities that we serve. Affordable housing is at the core of what Hacienda does, but we have been focused on developing multifamiliar structures. We have around 11 buildings in our portfolio, but 2 years ago, we received an allocation. Actually, we were working with the Port of Portland, as well as Judith was mentioned, and we received an allocation of $5 million to build a mass timber modular home. This came to our interest because as we were facing this housing crisis, we thought that probably with the traditional type of buildings that we have is not enough. So we want to bring to the table another alternatives and solutions, or alternatives to the solutions as well. So we developed this project named Más Casitas. The name is just a game of words, más for mass timber, but also in Spanish, when you say más, you say more, and casitas is like little homes. As I was telling you, we work this in collaboration with the Port of Portland. So we decided to explore mass timber, as Austin was explaining. This is a great material, huge environmental benefits. So we said, like, why not? It makes sense. We are not the experts, of course, but everything starts with an idea, and that's what motivated us to start exploring that. The idea also was to try to find a home product that we can use when people have lost their homes due to any like a wildfire or a natural disaster. And of course, also we oversee there the opportunity to continue doing like a workforce development. So real quick, what do we did during the year 2023? These we call prototypes because it was the first time that we were attempting to do that. We decided to do a full box out of MPP. We also work with Freres as our main supplier for the material. So we built 6 homes, 10 modules, and we decided to transport them to 4 different locations in the state of Oregon. As Judith was sharing, this was the first prototype that were built on the Terminal 2 of the Port of Portland. They have huge ideas now on developing a manufacturing facility there. We designed 3 different modules: studio, 2-bedroom, and 3-bedroom home. This is more or less how the home look like. We have 4-inch thick panels for the floor and the roof, and 2-inch thick panels for the walls. We decided to go with a permanent concrete foundation and with the insulation on the exterior. So here is the design that we came for the studio. You have like a space for the living room, dining room, the kitchen. You have the bathroom, some storage space, and at the back we have a restroom. Sorry, no, recámara, bedroom. Thank you very much. These were designed by Salazar Architects. They are here. Thank you very much. Some pictures here about the construction process. We decided to keep on the exterior all the conduit for the light, and just a regular installation of how as a modular constructions look like on the boxes. I don't know if the video is going to run, but I'm going to try. Okay, this is the first panel delivery that we received at the Terminal 2, and we start just like building in it from zero. Watch Construction was responsible for building the mods. More pictures. These were taken like when we have around 2 weeks that we have started the process. So yes, one of the questions we have is it faster to build with mass timber? Yes, it is. It took us around 10 weeks to go from the first delivery to the completion of the homes. Just for sharing with you the prototypes, the 6 homes that we built, we donated to other nonprofit organizations. This was great, Community Vision and Casa of Oregon. And I'm just gonna share with you some pictures of the end result of the homes. These were on Portland site. For this site, we designed like to have the 3-bedroom on the front, and the back we set the studio, kind of a ADU. Some pictures of the interior of the home personally, and then talking to some people that already live there. They love the feeling about the material. It is warm, they say. And this was the home that we delivered in Madras, and these two were replacement homes for a mobile park that lost all their homes during the wildfires in 2020. This family also received their home after it was a home replacement for the persons. They lost their home also on the wildfires. So here, Jill's asked me to share and to talk a little bit about the learnings and the challenges. So I felt like, yeah, on the learnings, as I was sharing with you, yes, is quicker to build with mass timber, is efficient. I feel like one of the challenges for us, for our team, I'm gonna say it like land use and zoning. We have like some challenges there, just trying to identify if we are gonna be, you know, like categorized as a manufacturing home or a prefab home, because they run on different programs or they follow different rules. So as we were putting this in different jurisdictions, there seems to be like kind of confusion there onto what is allowed or what is not. I think I'm gonna say also that the cost of the material itself is a challenge. We learned that it's expensive to build with this material. But I mean, it's part, I think, of the challenges that keep us like moving, the desire to continue exploring and to do the R&D required for continue using the mass timber for this material. So for us, the next steps is we want to integrate as much as possible all the learnings that we have from this prototype. We are designing right now a second version of the first mass casitas. We have partnered with Holst and with Blazer Industry. They are building modular as well. Walsh is part of our team also, and we are trying to define until what extent it makes sense to continue using mass timber. Of course, we have now this baseline, and we have learned a lot of stuff. And also, we are applying a post-occupancy survey to the people that is living there. We want to learn about the efficiencies of the home, the energies bills, if they have any feedback about the layout of the homes or wherever. So for us, I think like we shared this dream about to try to find scalability for continue building this type of project. So, yes.
Thank you. That's perfect. Answered all my questions. Is this still on? Yeah, okay. Anna, I'm coming to you. We can't pass the microphone all the way down. Okay, so you kind of represent also another aspect of this mass timber construction. You've been doing it more at the market rate in the urban areas. So just describe the housing. What types of units are you building with mass timber?
Sure. So there's a slight edit to that. The short stack projects are actually targeting the missing middle, and that's from a scale standpoint and also from an income standpoint. So there's a multifamily product and a cottage product, and mass timber was a part of the plan from the beginning because it helps us to create, as Judith noted, and it's kind of just a different pathway from that volumetric modular, a kit of parts to pull from. For those of you who know urban infill development, it's extremely high touch. So anything we can do to start to kind of make that process easier, that design process, that entitlement process. And we found that ideating around mass timber and its typical dimensions was a big boon for us in creating the short stack kit of parts. So when I say missing middle income level, we have 4 projects under construction or soon to break ground, just over 100 units. 3 of those projects are multifamily projects. The biggest one is 36 units, just to kind of give you an idea of it. And 1 is an affordable home ownership project. And all of those units will be either leased or sold at between 60 to 80% of the area median income. And as you know, Portland needs 120,000 new units of housing before 2045. And that missing middle segment is at least 30%. So we use mass timber to help us find efficiencies because it's a very tricky little area to work in because you're not necessarily being subsidized by public funding sources like a LIHTC deal, and you're not necessarily being supported by the market. So you have to kind of find efficiencies in any way you can. And mass timber is one of the ways we do that.
So can you talk a little bit about the costs that you're being able to bring these to meet that need?
Sure. So anybody who has looked at mass timber at the start of a project knows that it's more expensive to start. But what we've found, and it sounds like it's kind of not an argument, but perhaps a chorus we are all returning to, is that it goes faster. I've gotten through the superstructure on 2 buildings that are hybrid, so massed cross-laminated timber specifically, floors and roof, and panelized wood stud walls. And in both cases, we saved between 15 and 20% of the overall build time. And that's really significant. So you're lowering your general conditions on site. It's like less insurance. There's fewer people, less accidents on site, theoretically. And so those are some of the good reasons why we build with mass timber. And I did at one point reconcile my first hybrid mass timber project. I see my co-developer, Travis Phillips, in the room, the Child's House. And it actually came out to be more affordable to utilize mass timber, but that is a little economic hiccup. We happened to buy out our mass timber package prior to lumber prices soaring. So I do argue that it is cost neutral, if not slightly more expensive to build with mass timber. And keep in mind, I'm building not in a setting where it could take the place of concrete and steel. These are 3- and 4-story walk-ups. So the end result is also just like really beautiful and special. And when you're targeting middle earning people, it's important to, and any renter, any person buying a home, to create a real sense of place, and a place where people can let their nervous systems relax. And there's a lot of studies done, and Judith could probably speak to them, around this idea of biophilia and mass timber soothing people when they're in those spaces. And I've certainly felt that in them.
So how do you see the market in terms of is there room for more development of this type in the market, and what would it take for that to happen?
I think there's definitely room for more adaptation. Nathan mentioned how he's not going back. All of his floor cassettes are MPP now. And I think that it's easy enough to sub in mass timber. The details aren't that much more challenging, particularly in this hybrid system. I will say that, we do have a completely CLT cottage, and it is trickier when the walls are not hollow to detail, but it's kind of like very straightforward to use. And I recommend people do it because you'll save time. Some of the constraints in that regard are maybe a finite number of designated installers who claim to be mass timber experts. I didn't mean to sound like mean, who have cornered a market with mass timber install. But the reality is anybody with a large enough, I think, operation could probably self-perform install of mass timber as well. You just have to find a contractor willing to take that risk. Was that the question?
Thanks, Anna. This has been great. I want to leave some time for your questions. You have a lot of knowledge in this room. And I suspect there are some folks out here who want to ask questions of the presenters. Okay, this is tricky with one microphone. I'll repeat it.
Just curious, are you using MVP for both floor and the ceiling of the modules? And what thickness are you using?
So did you hear that?
So it depends on the application, on what the thickness is going to be, and whether or not we're using it in the ceilings as well. It depends upon what the finish goal of it is. The floors are a no-brainer for us, but the ceilings, it depends on how it's going to affect the MEP that we're trying to run within the unit.
There is on the cottages at this point, and I think that's kind of a bleeding edge versus cutting edge distinction with this technology still emerging. We couldn't offer the units at the price point we're offering it if we weren't heavily helped by public funding sources on that affordable home ownership grant. But the gap is not there in the multifamily. So that's a good question.
Yes. Okay, if you heard that, what have you learned about what the banks are looking at and how they're considering the houses?
So there's some real misconception. A true modular home is financed as a conventional stick home. It has no difference because it meets IRC, and if you do it on a commercial level, it meets the commercial international code and all local codes. It's only if you go to a HUD product, which would be a mobile home or manufactured home, that you're going to run into financing issues. So anytime that you build with offsite construction and you follow the codes, and you get the appropriate inspection processes, like we're certified through the state of Oregon and Washington and Idaho and a number of other states, as long as we go through the inspection process with that insignia, it is financed as a conventional product. And we've had very minimal issues getting financing over the last 15 years.
Tisha, did you have something to add?
Not really.
Okay. Yes. Does it affect permanent insurance costs at all? Anyone want to try that one?
Again, the question, please. Permanent insurance regarding the construction process or, yeah.
I think, yeah. I think the answer is it's certainly a consideration, but the material has been tested and is adopted by code in such a way that if you're meeting your hour ratings, that it's not treated that differently ultimately. And in fact, I think it should be a benefit.
That's exactly where I was going, is that in high fire prone areas, this is one of the things that we've been promoting about mass timber. One of the most frequently asked questions is, what about fire? And in general, of course, we do fire testing. It's one of the things we do. Some of you built campfires, you know that tiny little sticks are kindling and catch fire and burn up, but a big log will char on the outside and then insulate the interior of the log, which won't burn. And mass timber is basically the same. or depending on the rating you need to achieve by code, we build in a char layer so that even if it burns, there's enough remaining structural material that will keep the building up. And in terms of single-family houses, you get a single ember into a light wood frame house, it's gone, right? It's absolutely gone. And the advantage to building with mass timber is that it'll char and it'll take even a thin mass plywood panel will take a very long time relatively to burn through. So it should in fact result in, once the insurance companies begin to understand all this, because it's going to be a while and education is an issue, as Austin said, it should be an advantage because they're much safer. They can be more seismically resistant, more thermally resistant, and more fire resistant than conventional light wood frame. You asked me about it, about, yeah, about 50 different projects. So, there, yeah, no, I got it. We are doing testing, we're doing acoustic floor ceiling assemblies on, I don't know, many, many, many different assemblies. If you look on the Woodworks site, they actually have data on lots and lots of assemblies that have already been tested. We have some data on the assemblies that we're testing, but we're testing new assemblies all the time because depends on how thick your mass timber material is, whether it's mass plied or whether it's CLT, which acoustic mat you put on it, whether you put on gypcrete or concrete or anything else. So we think our acoustic lab will have an infinite number of things to test. In terms of fire, there's been a bunch of testing that has been done for just panels, beams, and columns. What is being done now and looked at by one of our researchers in particular, Erica Fisher in civil and construction engineering at OSU as a fire specialist, is looking at not just the individual components, but the entire structural system to see where the weak points are. Just like in seismic, they used to think that a lot of steel connections were just fine. The Kobe earthquake revealed that a lot of those connections were not at all fine. And the steel buildings actually failed at the connection. So it's one of the things that she's looking at now is the entire assembly and where the weak points in a fire might be to make the entire thing as safe as, say, a 2-hour rated panel. So the question is very, very complex to answer because there's a huge number of things, and it's why we have so many people working on so many of these questions. Yeah. Yeah. Yeah, Woodworks actually has a whole bunch of tested floor ceiling assemblies that you can find online pretty easily. Yeah. Mhm. Yeah, the assemblies are not rated for a particular building type. They're rated for particular hours. So whether you need a 1-hour rating or a 2-hour rating, and then that depends on the building type and the jurisdiction. Yeah. Mm-hmm. You know, it's interesting because we had originally thought we were going to make the flat packs, all the panels with insulation and cladding on the outside. We spent a kind of ridiculous amount of time actually detailing that. And even before we built the first prototype, we were pretty sure that was not the way to go. And it meant that all the steel attachments had to be done on the inside. And we also were a little concerned about what happens when you stack a bunch of these and, will the insulation or cladding get damaged? So we're now moving to something that is just, and that's the second optimization process we're going through for the second one, is that it's really going to just be the mass plywood panels with basically a kit of parts. We have, files that will be ready for anybody to put through a CNC to cut. But that once those are cut, the package would contain a series of pre-cut panels, steel connections, and screws, and theoretically, a set of instructions that are easier to understand than IKEA's, and probably mostly in English. At least that's the idea. For the retrofit project, we're going ahead with this idea about the insulation and the cladding and everything being on at once. Those are at a bigger scale, and those would definitely have to be put on with a crane and shipped in a slightly different way than what we're imagining for the flat pack one. But that's the idea of it. Yeah. Mm-hmm. Well, first of all, you can't put your foot or your fist through a mass plywood wall. Go ahead, try, right? So that's the first thing. The second thing is we did in our little unit, we're doing wall hung toilets for a variety of reasons. It makes the plumbing easier, but because we've got a big, strong 3-inch plywood wall, mass plywood wall behind it. So you can hang anything or attach anything to it. I think, the bigger question is, can you cut out walls and move them around? The short answer is no, you cannot. And that would be insane. And people do that a lot in houses where they don't actually think about whether their lightwood frame is actually load bearing or not. It's not a good idea, right? So because at least in our design, all the exterior floor ceiling are 3-inch, the interior partitions are 2-inch. Theoretically, you could move those, but with the kind of tight design that's there, that would be difficult. I think that, in the future, you could certainly make arrangements where you have a mass plywood shell and you have partitions on the inside that could be 2-inch, could be thinner, that could be moved around. But for the first pass, we're not envisioning. I mean, you could take a saw to it and cut a hole, but again, we don't really recommend that, right? Yeah, you can, in fact, if you had to, you can shore something up and patch something back in. That's entirely possible. I mean, if something floods, right, you have to tear out all the gypboard, at least with mass plywood, give it a couple of months and it can finally dry out and hopefully you can save it from delaminating. But, it's a problem with any building that you have a flood or a fire or anything else in. I don't know why I'm answering all of this, but we do a lot of work in this area, as you can imagine. Somebody, Austin?
Just far as the weather resiliency of the panels, they're pretty impressive. Far as what they can withstand, we have had panels sitting outside for 6 years and they're still holding together. But obviously, yeah, if there's a leak and it's not caught for a long, long time, that could be a big issue. But it's wood, right? It's better than concrete or that's a lot more permanent. You can cut and replace and patch wood, and that's one of the good things about it is it's not a huge step away from like contractors that have worked with wood, and also the steel erectors as well because they're used to picking stuff in place. The other thing I was going to add on top of that question is, theoretically, all these panels can be reused too. So at the end of the life cycle, right now, reclaimed wood is really big, right? So theoretically, all this mass timber can be, if the building's torn down, it could be disassembled, because most of the stuff's put together with screws. So that is a consideration.
The example, right?
Oh, right. Well, or Nathan, you could talk about it because you just saw it. So we had this very large 3-story lateral force resisting testing project, earthquake, in our lab. We've got this huge 3-story wall with giant actuators so we can mimic all kinds of forces. And after the testing was done, we had a huge amount of 7-inch mass plywood that we did not want to see go to landfill. So instead of building a new 3-story building out of it, unfortunately, we couldn't do that because there is no current process in place for structural recertification of used panels, which is, I think we're moving in that direction, first with glulam's, then with it, so we could do it. But we actually had to look for a non-structural use for it. And actually the panels, most of those panels have gone into partitions in our new University of Oregon Highland Hall, which is the Department of Architecture building on the new UO campus just a little bit north of here, which we're very excited about. So we had them refabricated in our Emerson lab after being tested, and they're now being reused as non-structural partitions. But we hope in the future, and Nathan just saw me presenting this, I guess it was Thursday, but we're hoping that in the future there will be a structural recertification process, though we don't expect there's going to be a lot of mass timber projects that are going to be torn down for reuse soon, but it's still something we need to plan for. Yeah.
Yeah, another part of the material is the resiliency. So, we did, or we were a part of a 10-story shake table test, full size table in San Diego. And so, and they went through hundreds of earthquakes, larger than we've experienced. And, I don't know, they're like 1,000-year occurrence level earthquakes, and the panels were perfectly fine. And so the idea is, so in some of these concrete and steel buildings, when they go through earthquakes, they have to be demolished. And so the idea of some of these mass timber shear wall designs is you can just replace elements and the building's still good. And so that's where resiliency is becoming a design consideration. So we're not tearing down these buildings when they go through a catastrophic earthquake. We're just replacing these key elements. The main structure stays in place.
Tell you what we did, if that's because we spent way too much time on it. We, you've probably seen this in commercial buildings, with CLT. They often leave a gap between panels to run the electrical. And that's what we did in that little house. We actually have a gap there, and then the rest of it is actually running around baseboards and ledger beams. And we also have, switches that we just routed out into the wall that are wireless, so that you just touch them, and so that we didn't have to absolutely wire absolutely everything. For MEP, we're trying to keep the price down as much as possible, though we're also going for Anna's middle housing, which is what we're aiming for. But we decided that mini splits were too expensive. So we actually have electric resistance heating under the windows. We have an HRV unit that's kind of buried between two beams on the ground floor that is routed up through the closets. And we have a very high-tech air conditioning unit it's very low tech. It's like $500 that is in the wall. And we will be doing thermal testing outside. The thing is, it forms such a tight thermal envelope that, and we've already done some preliminary testing. We developed something called an energy shutter, so that instead of using vinyl windows, which we don't think are that nice, we're using a double pane casement aluminum window. And the third pane is formed by a sliding polycarbonate shutter that has some insulation in it that works as a kind of privacy curtain, but also adds a third layer for insulation. And we've done blower tests with a mock-up for that. And because the windows fit in so tightly because of the precision of the prefabrication, the thermal envelope is unbelievably tight. So we will have some data on that once we get the second prototype up, and we're going to do thermal testing, thermal, acoustic, indoor air quality, a whole bunch of other testing of that. But it's something that we're looking forward to.
With the short stack multifamily, we are stacking the same kind of units over one another. And then there are chaseways like down the center of the masses that we have a drop ceiling. So we run as much as we can from an electrical HVAC standpoint in that drop ceiling, because it's just the bathroom and the closet. And then when we do have to pop out of that, we just have a really, really nice conduit set super nicely. I think it's kind of like a European vibe. It's not quite as common here, but you do also have the option of like dropping it in from above and just like landing it. So there are options, particularly with the hybrid walls. You have a lot more flexibility. And we use PTACs in ours too. Those like through air under the window units. So not quite mini splits, but not $500. Where you getting yours at? Okay.
Not the heating.
Anybody else?
I would like to ask a question for you, Nathan. What do you think there is the challenge for mass production from your perspective? Because I've been hearing like there is a lot of attempts for trying to design and to mass produce mass timber modular homes, but I would like to hear from your perspective.
Yeah, so In order to mass produce anything, you have to go back through the process and look at how you're gonna build it. And so I always use the example of an iPhone. An iPhone is completely standardized. Every single one of them is exactly the same. You can industrialize the process to be able to get to the end goal. The problem with housing is we always build an individual, unique building that'll never be built again. So there's very little industrialized engineering that goes into the process. In order to mass produce and quantify the product that we're trying to do, we have to industrialize the entire process, which means we change the paradigm of the architecture and design and engineering to be something that's going to be a one-off. Instead, it has to be a collaborative process between the manufacturer and the end goal of the client that you're going to sell them to. So what we're focused on is trying to implement as many of the industrialized construction processes into our system and our process, which works beneficially with what they're doing with the MPP because of their CNC and everything that we can do by taking the time in an industrialized process to actually allocate the position of a plumbing pipe or anything else that we want to have pre-routed out so that the system becomes more efficient on the end side. So many people have tried it. The problem is that a lot of people that get into it don't think about it from a manufacturing standpoint. They think about it from a construction process. I was chucking a truck that moved into a facility 15 years ago and didn't understand manufacturing. And after being in a facility for 15 years that we've had, we understand throughput of product, how to get in finished products out one side, and the whole process is much different. And it took us years before we'd ever say manufacturing because we didn't want to be associated with manufactured housing. But the true goal of this is it's not about building one thing. It's about working with your design and engineer team, which has to be a collaborative process, or else there's a deficit in funding that occurs there because there's no incentive for an architect to design something that can be rebuilt over and over again. So then you have to focus on what Mike at Walsh talked about years ago, which is 80% of the building. 80% of the building can be rebuilt over and over again. 20% is left to the accoutrements that are going to beautify the building. Focus on what can be done, not what can't be done.
Thank you.
Are you, so there, I appreciate that. And then there's still like some messy construction that has to happen, like civil work. Are your mods like landing on slabs? Okay.
Can't get away from them. You can't get away from the site components or the slope sites or the foundations that we put in. I mean, we've only landed a mod on a single, I think yesterday was the first time we've landed a mod on a 2-foot stem wall. We've always had basements. We've always had tricky sites. We've always had all sorts of things happening that you can't get away from. And so when you're doing high-end single-family homes, which we've done for the last 5+ years since COVID, you spend just as much time in the factory as you do on site. There's no way around that. What I'm talking about is what you can control, and what you can control is from the plate up. And that's what you focus on. You can't, again, don't worry about what you can't fix. Fix what you can. And that's what the goal is of what we're trying to strive for. We still have to get an excavator and dig a ditch. We still have to run a sewer line. We still have to run a foundation. We still have to pour concrete. There's no way around a lot of those components, and we're not trying to attack those because to us, those aren't a high use system to go after. But what is the implementation of applying 2 pieces of wood together to build a house and all the other components. It's not just that. Our focus is on the industrialized process and centralization of production. So we reuse the same subs over and over again. And our sub core is just as important to us as the design side, nothing against Drew or Keegan, or the engineering side or anybody else, because the implementation of a true electrician looking at these processes is what gives us the best results. Anytime we stand back and tell them where to put something, it never works, right? And everybody that's been on a big project always knows that it becomes a fight between everybody working together. We oftentimes have the plumbers, the electricians, HVAC, and sometimes fire all in the facility at the same time in different modules doing different things, but all working together to try to figure out how to get to the end process.
Another question, just real quick. Which level of automation does your manufacturing facility has?
So I don't necessarily believe in automation because we haven't gotten to standardization throughout the design process yet. So what we focus on is kinetic energy or physical input that goes into the manufacturing of the building. So we have automated nailers we have nailing systems that are mechanized, but yet auto in the sense that you can push a button and it'll drive multiple nail guns at the same time. We have unit saws that can cut, which is pre-MPP, where we would cut entire units of lumber to length within 7 minutes. We have different stations set up for being able to do pre-cutting and routing and other things. So, and we have We also, in our conventional floor systems, we use a lot of 2x12s, which are 11 1/4. Our LVLs are 11 7/8. Talking fast, but I'm trying to get through all this. So we used to have to rip all the rims down, which was a whole nother process. So when we look at all of the physical inputs that go into it, my job as the owner is to try to look at how to get rid of the repetitive tasks that go into the build process so that we can better utilize the knowledge base of our employees to be able to put things together to higher and better use. So I don't believe mechanization or automation is there yet.
They're asking, do you see mass timber replacing concrete in podium-type buildings?
As far as the podium itself, yeah, I think it absolutely can, and we have some developers that are really interested in that, and they think that it could certainly pencil out. There is a rolling shear is a design structural design point that needs more research there, and with that podium slab, there's a different in the grid system that you're going from above and below, so that's a hurdle.
Yeah, well, transportation is a big cost for as part of the project. For us, the side that we deliver further was talent, and of course, I felt like that could be like kind of a restriction from where you are as a manufacturing facility, and you can travel. But also, I've been learning that you have facilities that build modular homes in California and they sell in Oregon or vice versa. So I feel like yes, transportation is part of this of the cost component, but it's a way to manage it. So I don't know, Ethan, if you want.
Yeah, so we've shipped modules. Well, we've shipped panelized up into Canada. We shipped modules all the way up into Seattle. We've been to Las Vegas. We've been to LA. We've been down to San Francisco multiple times. But there is definitely a cost, and you're starting to see that more in the last 5 to 10 years as a lot of the super truckers are starting to retire, because it is a specific skill set to get somebody to get behind a 16-foot wide by 60-foot long module and run down the freeway at 60 miles an hour. And so we're starting to see the prices go up a little bit more. So it's definitely a design, or it has to be implemented into the performer from the beginning. But there are companies starting to come online with more trucks and more drivers to start driving that price down.
I just wanted to add that in the utilization of CLT in my project, we used the standard shipping pallets as a constraint of the size of the panels we were picking. So it wasn't an oversized load. Our panels, I think, are 10 feet wide, which is still fits into that regular trucking. So I just wanted to note that.
Yeah, we made the same decision that our panels are no more than 10 feet, and we're trying to get them down to 8 feet. So that, again, I think there's room in the market for both, for volumetric modular and panelized. And it's good to have a number of alternatives that could work.
Well, that's a great question. Yes, I think regarding the mass timber material itself, we really do not face like any challenge. The challenge was to try to establish the conversation with those different jurisdictions, because we realized that they lack of like information regarding what is a manufacturing home, and what is a prefab. In our case, we run the prefab program, and those are just like following the local or the state building codes versus a manufacturing home that it follows the hot regulation. So over there, I felt like with full transparency, there's still work to do for them to keep on learning what those differences are and what apply to what. I know also that recently, for example, they passed a bill, I think the 6404 bill, where they allow to build prefab homes in manufacturing mobile parks, and it has to do only with the way they attach to the ground, which type of foundation you are using. But the state also is doing an effort to try to standardize and also to try to allow this type of constructions more amplitude. Yep.
And I have one final question for everybody. So we'll start with Anna and just go down the line. What's your vision for the future of housing built with mass timber over the next 5 or 10 years?
I hope more developers try it and use it. Sorry, it's kind of a stupid answer, but I think that people should just try it. It's not scary. Just try it.
Instead of just do it. Prayers, just try it.
Yeah, that's great. Thank you. I think for me, I would like to see more collaboration. As I participate more and more in this type of exercise, I feel like we are all running behind the same or towards the same goal. And I don't see why this should be like separate efforts. I think that we should learn to collaborate more and learn from each other. So that's my dream for one side. And on the other, I would say I hope the state give us resources for continue the R&D. Sometimes people is like, oh, you're crazy, you're producing a mass timber the way you did it, but you have no idea how many learnings do we have from that, and the possibilities and the doors that this open. So I would say innovation is part of the equation here.
Yeah, thank you. We feel that that's our job, or is right, the funded innovation piece. But we have said our Oregon Mass Timber Coalition, which is this group, the 2 public universities with a bunch of state agencies, we've had this, forest to factory vision where, you can decrease wildfire risk by more selective harvesting. And selective harvesting is expensive, but if we can create a market like at Frere's and other places for the products of all that harvesting, it can be market driven. So we can reduce wildfire risk, create more fiber supply, driving down the cost of it, create more high-tech logging jobs and more highly automated manufacturing jobs in factories like the Frere's factory or the new Timber Lab factory that will be opening up. And then we hope through prefabrication create vast numbers of quickly produced, incredibly resilient mass timber housing. 5 to 10 years. Yeah. 5 to 10. No, it is. That's exactly what we've been predicting. 5 to 10 years. We think it's actually 10 years out, to get a whole bunch of manufacturers making the stuff and getting the housing out there. And that's the vision. Yeah.
What was the question again? In 5 to 10 years? Oh, we're going to do a lot more of it. I mean, that's where we're heading. I mean, I think as we start to understand what the product can do from a biodirectional standpoint, as far as design and engineering standpoints, the more that we start to encumber our engineers to figure it out and our architects to be able to implement it into the design, you're going to be seeing it utilized in different applications that are going to benefit the construction process, because we have to keep in mind that we're losing our skilled labor at a rate that we've never seen before. And so unless we componentize the build into fewer number of parts and pieces, we're going to have significant issues with ever trying to reach any kind of housing crisis solution.
I think I would like to answer that, and I'm very excited to see where we can take it from a design standpoint and really start to create an aesthetic that it is really distinguished and has the narrative of the energy, the carbonization, and start to basically create a brand around it?
I see it the way, kind of more what I hope. You know, there's a lot of demand for it right now, and it's growing, you know, through a lot of innovators in the industry. And it, you know, I'm going to go back to timber supply. It really depends on that timber supply, because if it doesn't get competitive financially, then it's going to die, and or we're going to outsource, right? So, you know, I just hope policy eventually starts understanding, you know, just as a general statistic, we grow 3 times more timber volume than we currently harvest. So there's an enormous amount of volume out there to harvest. It's just a matter of changing policy to harvest it. And then just going back to the buying local, you know, there's a lot of mass timber coming in from Canada and Europe because it's cheaper. And so they can ship it all the way across seas, and it's less expensive. And, you know, that's taken a lot out of the sustainability. So I just, I hope in the next 5 to 10 years, we're able to support, you know, these innovative uses and, you know, make housing more affordable. So.
Thank you. Let's give them a round of applause. Are you guys gonna be around for questions if anyone wants to?